Hi everybody. In this video, we shall introduce the so-called DeMorgan's laws that are used commonly in set theory. The first law is written on your screens, which is A union B whole complement or whole negated, and this equals A complement intersection B complement. And we shall prove this law using Venn diagrams diagrammatically. So to do that, first of all, let's visualize the left side of this law, that is A union B whole complement. We are going to draw Venn diagrams and see how that looks like. So suppose we have a set A represented by this circle and another set B, which is now also drawn alongside the same circle. And if we put them together, then the joint area that is formed by combining both the sets is called A union B. So this involves the elements of A as well as the elements of B, hence the union. Now what is A union B whole complement? Remember, we set out to show what does the left side of this law look like in a Venn diagram. So how does the A union B whole complement look like? So in other words, what's outside the combined space of A union B? Now to do that, we must draw a universal set around them. So A union B whole complement is all the space in the universal set outside A union B. So we have visualized the left side of the law. Now we are moving to the right side of the law, and we'll prove that the right side also looks the same as this. So keep this diagram in mind, and in the next slide we shall show what it equals to. Now let's visualize the right side of the equation in the last slide. That is A complement intersection B complement. So again, we draw A, and the space outside is called A complement. Similarly, let's draw B and B complement. Now, we have to draw their intersection, so we have to bring them together in the same diagram. So let's see what is A complement intersection B complement. Well, it is a space that is neither in A nor in B. Therefore, it is a common space outside both A and B. To do that, let's draw both A and B in the same space. And now get rid of both A and B. Remember, because we want to show the space outside both A and B. So now we can clearly see that the only space left is what represents A complement intersection B complement. And you may remember what you saw on the last slide, but let's bring back the last picture from the previous slide here. And if you just ignore the color scheme, I hope you agree that the two diagrams look identical. Hence, we prove that A union B whole complement equals A complement intersection B complement. So, hence there are two DeMorgan's laws. The first is what we just proved. And the second is A intersection B whole complement equals A complement union B complement. I'm going to leave that as a personal exercise. You can draw the Venn diagrams for yourself. But there's an easy way to remember these laws. Remember that in both the cases, you open the brackets and put the complements on A and B. Also note that union and intersection are inverted after opening the brackets. For instance, in the top law, A union B whole complement, once you open it, it becomes A complement, and B turns into B complement, and the union in the middle gets inverted to become intersections. It literally becomes inverted. As you can see, that it becomes upside down. Similarly, for the second law, you can apply the same chain of reasoning. So A intersection B whole complement, you open the bracket, so it becomes A complement, and B turns into B complement, whereas the intersection in the bracket now turns upside down, it gets inverted, and it becomes a union. So let's now do an example. Suppose the universal set contains numbers 1 to 8. Set A contains elements from 1 to 4, while set B has numbers 3 to 6. So there is some overlap between the two sets as well. So A union B contains the members drawn from both the sets A and B. But notice no member is repeated. For example, 3 and 4 appear in both A and B, but they're not repeatedly written in A union B. So we can now compute A union B whole complement. And to do that, we remove all the elements of A union B from the universal set. And what remains is 7 and 8. You can pause the video and try it out yourselves. And it's really easy. Just strike out all the elements that appear in A union B from the universal set, and you will arrive at the same result as on your screens. Now we compute the right side of DeMorgan's laws as well, which is A complement intersection B complement. And to do that, we must first compute A complement. So that means we take out all the elements of A, the set A, from the universal set. Again, you can pause the video if you want and work it out yourself. But when you remove all the elements of A, you get remaining elements from the universal set, which are numbers 5 to 8. Similarly, B complement is 1, 2, 7, and 8. Then we compute their intersection, that is elements in both A complement and in B complement. For your convenience, I have already colored them red, so you can clearly see. So hence, A complement intersection B complement gives a set comprising of two elements, that is 7 and 8. And this is the same as the set A union B whole complement. Hence, we prove the law with this example. And that concludes this video. We shall see you in the next one.